Mr.P Shantan Kumar, Department of Mathematics, Assistant Professor, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today's topic is the linear differential equations of the second and higher order with constant coefficients. In previous class also, we discussed based upon the linear differential equations of the second and higher order with constant coefficients. But today also, we are going to discuss another method by using the characteristic equation method. And before going to discuss here, once again we need to discuss what is the definition of the higher order linear differential equations of the constant coefficients. An equation of the form that is a d power n y by dx power n plus p1 into d power of n minus 1 y by dx power n minus 1 plus pt into d power of n minus 2 into y by dx power n minus 2 plus up to so on, that is a pn into y is equal to q of x, where p1 comma p2 comma pn are the real constants and q of x is the continuous functions is called the linear differential equations of the nth order with constant coefficients. Now we need to consider that capital D is equal to, that is a d by dx, and d square is equal to d square by dx square, d cube is equal to d cube by dx cube, and similarly there is a d power n is equal to d power n by dx power n. And similarly, while we are going to multiplication with y, that is a dy is equal to, that is a dy by dx, d square y is equal to d square y by dx square, and similarly d power n into y is equal to d power n y by dx power n. Hence, the solution of this linear differential equation is a complementary function that is denoted CF plus particular integration is denoted, that is a PA. Therefore, that complementary function plus particular integration is the complete solution of the differential equation. Now, we need to find out what are the complementary function, that is a solution methods. While we are going to discuss that complementary function, first we need to write what is the auxiliary equation. The auxiliary equation is obtained with the help of the M equation, and based upon the M equation, that is auxiliary, while we are going to solving that four cases are available. One is that m1 comma m2 is a different root. That means m1 comma m2 up to so on mn are the real and different roots. Then we need to write in the form of yc is equal to c1 into e power of m1x plus c2 into e power of m2x plus up to so on cn into e power of mnx. And if it is the roots are the equal and remaining roots are the different, that means we assume that m1 comma m2 are the repeated, the two roots are the repeated. Therefore, the complementary function that we denoted yc is equal to, that is a c1 plus c2x into e power of m1x is a value. Now, we need to discuss, that is a third case, whenever the roots are the complex roots. That means the roots are the alpha plus or minus psi beta, where alpha is the real part and beta is the imaginary. With the help of the real and imaginary part, we need to write in the form of complementary function is equal to e power of alpha x into c1 into cos beta x plus c2 into sin beta x. Now, we need to discuss, that is a fourth case, that is a roots are the surds, or that is nothing but irrational you consider. Therefore, with the help of the condition irrational or surds, that is alpha plus or minus root beta. And here also that alpha is we need to write in the form of e power of alpha x, and the surd is nothing but that is root beta. You need to consider c1 into cos root of beta x plus c2 into sin root beta x is a value. By using these are the four cases, we need to do the problems. Other terminology, by using the characteristic equation, that is in terms of the L. Therefore, the linear homogeneous differential equations of the nth order with constant coefficients can be written as, that is a y power n of x plus a1 into y power of n minus 1 into x plus up to so on an minus 1 into y power of n dash into x plus an into y of x is equal to 0. And here also that a1 comma a2 comma up to so on an are the constants which may be real or that is a complex. And when we are going to representing this is with the help of the L of d, that is L of d into y of x is equal to 0, where that L of d is nothing but it is called as an operator form, that is nothing but the characteristic equation. Consider that L of d is equal to d power n plus a1 into d power n minus 1 plus up to so on an minus 1 into d plus n is a value. Now, that operator form we need to write in the form of the characteristic equation by using the symbolically lambda, that is L of lambda is equal to, that is replacement of D is equal to lambda. Therefore, L of lambda is equal to lambda power n plus a1 into lambda power n minus 1 plus up to so on an into y lambda plus an is a value. Now, we need to write in that auxiliary equation, that is a algebraic equation, that also that L of lambda is equal to lambda power n plus a1 into lambda power n minus 1 plus up to so on an minus 1 into lambda plus an is equal to 0. This equation is called, that is a characteristic equation of the differential equation. And as it is, here also we need to find the solutions, that is based upon the 4 categories. Whenever the characteristic equation solving, if you get the roots are the different, that means with the help of that y of x is equal to c1 into e power of lambda 1x plus c2 into e power of lambda 2x plus up to so on cn into e power of lambda nx. That means here you assume that lambda 1 comma lambda 2 comma up to so on are the roots of the differential equation, that is a different value, that c1 comma c2 up to so on cn are the constants value. Similarly, the roots are the equal, that is nothing but you consider c1 into e power of lambda 1x plus c2x into e power of lambda 2x plus up to so on, that is a cn into x power of, that is a kn minus 1 into e power of lambda mx is a value. For example, the roots are the complex. The complex are also different complex roots. Therefore, with the help of that, you assume that lambda alpha plus or minus I beta and gamma plus or minus I delta value. Therefore, one of the complex different roots, that is with the help of the real and imaginary parts, that is e power of alpha x into c1 cos beta x plus c2 into sin beta x. And similarly, the second other complex roots with the help of the real and imaginary part, e power of, that is a gamma x into c3 into cos delta x plus c4 into sin delta x is a value. Now, we discussed that is a case 4, the roots are the complex and the complex roots are the repeated. Therefore, we need to consider in the form of y of x is equal to e power of alpha x into c1 cos beta x plus c2 sin beta x plus x into e power of alpha x into, that is a c3 cos beta x plus c4 into sin beta x. Plus similarly, in finally that is a repeated root of the complex, with the help of that x power of k minus 1 into e power of alpha x into c2k minus 1 into cos beta x plus c2k into sin beta x is a value. These are the 4 different cases when we are going to solving, that is a complementary function. Now we'll go to discuss some of the problems. Let's solve the differential equation y triple dash plus 2 into y double dash minus y dash minus 2y is equal to 0. When we are going to reduce it to like the characteristic equation, that means in terms of that is a lambda, this is also known as that is an auxiliary equation, that is we discussed in the previous classes, that is in terms of m only. Now we'll go to discuss that is a characteristic equation in terms of lambda. Therefore, the lambda is the order of the differential equation is that is a third order. Therefore, while we are going to solve this in the lambda cube, we obtain that is the 3 roots of the equation by using the synthetic division or by using the factorization method. By using that methods, here clearly the obtain the solutions are lambda is equal to minus 2 and lambda 2 is equal to 1, lambda 3 is equal to minus 1. That means the roots are here all are the different roots. With the help of the different roots, case 1, that is a y is equal to c1 into e power minus 2x plus c2 into x plus c3 into e power of minus x. That means c1 comma c2 comma c3 are the arbitrary constants. Here, solve the equation y triple dash minus y7 y double dash plus 11 y dash minus 5y is equal to 0. And here also, when we are changing to like that characteristic equation, that is in terms of lambda, you obtain that is a lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. Here also, the order of the characteristic equation is a 3. Therefore, here you obtain the required the solutions are the 3 only by using the synthetic division or factorization method. And clearly it is equal to, you obtain that lambda is equal to lambda minus 1 whole square, lambda minus 5 is equal to 0. That means lambda is equal to 1 is repeated and one other third root is a different root. Therefore, by using the case 1 and case 2 with the help of the two cases, while we are going to consider the solution is a y of x is equal to c1 plus c2x into e power of x plus c3 into, that is e power of 5x is a 1, where c1 comma c2 comma c3 are the arbitrary constants. Now solve the equation y fourth derivative minus y triple derivative plus 2y dash is equal to 0. And here also, when we are changing to, that is a characteristic equation, that is in terms of lambda, that is a lambda power 4 minus 7 minus lambda cube plus 2 lambda is equal to 0. Here also, the order of the equation is a 3. Therefore, clearly in this equation, we need to take out common lambda outside. Therefore, lambda into lambda cube minus lambda square plus 2 is equal to 0. Therefore, by solving this equation, once again, the lambda is equal to, that is a 0. And with the help of that third order, you obtain that lambda is equal to minus 1 and also 1 plus or minus I is a value. That means the case 1, it is 0 comma minus 1 is a different root, but whereas 1 plus or minus I is a complex. That means the case 1 together, that is a case 3. Therefore, that you need to write y of x is equal to c1 plus c2 e power minus x plus with the help of the complex e power of x into, that is a c3 into cos x plus c4 into sin x is the value. And here also the c1 comma c2 comma c3 comma c4 are the arbitrary constants. Now we need to solve that y fifth derivative plus 18 into y triple dash plus 81 into y dash is equal to 0. Here also, when we are changing to like the characteristic equation, that equation is clearly, there is a lambda power 5 plus 18 into lambda cube plus 81 into lambda is equal to 0. Therefore, here also the lambda is a common thing, it is available. Therefore, lambda into lambda power 4 plus 18 into lambda square plus 81 is equal to 0. And moreover, that within the bracket the equation is also we need to write, that is a lambda square plus 9 of whole square is equal to 0. Therefore, the solutions of here, the lambda is equal to 0. The other lambda is equal to, that is a plus or minus 3 is a repeated complex value. Therefore, with the help of that different category and together the complex repeated, that is case 1 and case 4, with the help of that, you need to write, that is y of x is equal to c1 plus c2 plus c3x into cos 3x plus c4 plus c5x into, that is sin 3x. And here also that c1 comma c2 comma c3 comma c4 and also that c5 are the constants values. Now solve the differential equation y fourth derivative minus 4 into y double dash, the 5 triple dash plus 5 into y double dash minus 4y dash plus 4y is equal to 0. Again here also, when we are changing to like that characteristic equation in terms of lambda, that is a lambda power 4 minus 4 lambda cube plus 5 lambda square minus 4 lambda plus 4 is equal to 0. Here also, by using that synthetic as well as the factorization method, you obtain clearly, that is one of the root is lambda is equal to 2 comma 2 is repeated and lambda square is equal to plus 1 is equal to 0 is nothing but lambda is equal to plus or minus I is a value. Therefore, the roots are here lambda 1 comma, that is a 2 is equal to, that is a 2. That means that lambda is equal to 2 is a repeated root and lambda 3 comma 4 is a plus or minus I is a complex. Therefore, the combination of the second case and fourth case, we need to write, that is a y of x is equal to c1 plus c2x into e power of 2x plus with the help of the case 4, case 3, that is a complex, that is a e power of 0x into c3 into cos x plus c4 into sin x. That means final the solution is a y of x is equal to c1 plus c2x into e power to x plus c3 into cos x plus c4 into sin x is a value. And here C1, C2, C3 and C4 are the constants values. Now we need to discuss that is one other different by using the initial value problem. Find the general solution of y triple dash plus 4y double dash minus 7y dash minus 10y is equal to 0. And second also, continuation of this problem, they are asking to find out the initial condition with the help of. That means with the help of that equation, that is the first one, we need to addition of the initial value problems, we need to find out what about the C1, C2, C3. That means first we need to find out what about that characteristic equation and roots of the equation. Therefore, there is a lambda cube plus 4 lambda square minus 7 lambda minus 10 is equal to 0. Here, the order of the equation is 3. And again here, by solving this is the equation, we obtain that is equal to lambda is equal to minus 1, lambda is equal to 2, lambda is equal to minus 5. Therefore, here the roots are the three roots are the different. According to the case 1, we need to write the case 1, the solution y is equal to c1 into e power minus t plus c2 into e power 2t plus c3 into e power minus 5t. Therefore, here the c1, c2 and also c3 are the constants, there is a parameter, and continuation of the second problem by using the initial value problems. Therefore, by using the initial conditions of here given, y of 0 is equal to minus 3, y dash of 0 is equal to 12, y dash of 0 is equal to minus 36. That means that a solution we need to replace at x is equal to that is a t is equal to 0 and y is equal to that is a minus 3. Then you obtain clearly c1 plus c2 plus c3 is equal to minus 3. And by using the equation of equation 1, the derivative with respect to x, and again after that you need to replace with the help of the second y dash of 0 is equal to 12, you obtain that is equal to that is a minus c1 plus 2c2 minus 5c3, psi c3 is equal to 12. And once again, one more time with respect to derivative, after that replacing that is a t is equal to 0 and y double dash is equal to that is minus 36, you obtain that clearly that also that c1 plus 4c2 plus 25c3 is equal to minus 36 is the value. Now we need to solve, these are the three equations. By solving these three equations, you obtain that clearly that c1 is equal to minus 5 by 2 and c2 is equal to 1, c3 is equal to minus 3 by 2. Therefore, the solution of the given differential equation is clearly that is y is equal to minus 5 by 10 into e power minus t plus e power of 2t minus 3 by 10 into e power of minus 5t is a solution. Next. Find the general solution of y fourth derivative plus 8y double dash plus 16y is equal to 0. And here also, the second one is also continuation of this problem. We need to find out by using the initial value problems. That means you need to find out what about the c1, c2, c3. Therefore, we need to write the characteristic equation, and by using the solving the characteristic equation, we obtain the roots are clearly that is lambda is equal to plus or minus 2i is the repeated complex number. Therefore, according to the repeated complex number, we need to follow that is the fourth case, that is equal to c1 into cos 2t plus c2 into that is a sin 2t plus c3 into t into cos 2t plus c4t into that is a sin 2t. Therefore, by using this is the solution, we need to, by using that initial value condition, once again, by solving that everything, we obtain that is clearly the solutions are c1 is equal to minus 1, c2 is equal to 2, c3 is equal to 1 and c4 is equal to minus 3. These are by using the initial value conditions. Therefore, getting that c1, c2, c3 and c4, you replace in the equation that is a y. Therefore, y is equal to that is minus into cos 2t plus 2 into sin 2t plus t into cos 2t minus 3t into sin 2t is a solution. And here also the other method is also available, but it is not that equal. Next one, solve that d square minus 3d minus 4 into y is equal to 0. And we will go to discuss by using the operator form as well as there is auxiliary equation. Therefore, the operator form is nothing but that is replacement of d by dx is nothing but dy by dx. Therefore, the problem is clearly given operator form. Therefore, we need to write in that what is auxiliary equation. Therefore, the auxiliary equation is nothing but the replacement of here, the d is equal to that is a m value. Therefore, that replacement of d is equal to m, therefore m square minus 3m minus 4 is equal to 0. Therefore, by using this equation, that is solving this equation, you obtain that m is equal to minus 1 comma 4. That means the roots are the different category. Therefore, according to the different category, if you want to write in terms of that AB or C1, C2, that's complementary solution is a in t power of minus x plus b in t power of 4x is a value. That also, if you want to write in terms of the summation, that is a C1 constant, C2 constant, C1 in t power of minus x plus C2 in t power of that is a 4x is a solution. Both are the same. Next one, solve that 9y double dash minus 12y dash plus 4y is equal to 0. When we are going to consider in terms of that operator form, that is nothing but replacement of d is equal to d by dx, d square is equal to that is a dy by d square by dx square is a condition. Therefore, the operator form is a 9d square minus 12d plus 4 into y is equal to 0. Next, the auxiliary equation is nothing but replacement of once again d is equal to m is a value. Therefore, there is a 3m minus 2 whole square is equal to 0. By solving this equation, that is m is equal to, that is clearly the 2 by 3 comma 2 by 3 is a solution. That means the roots are the real and also which is equal. Therefore, the complementary function is nothing but that is in the form of ax plus b into e power of 2x plus by 3, that is by using the second category. Otherwise, you need to consider that is a c1 plus c2x into e power of that is a 2 by 3 into x is a value. Both are the same. Next one, solve that d square y by dx square minus 4 into dy by dx plus 5y is equal to 0. While we are going to change it to like that operator form, that equation is clearly that is a d square minus 4d plus 5 into y is equal to 0. Next, the auxiliary equation is a m square minus 4m plus 5 is equal to 0. By solving this equation, you obtain that clearly that m is equal to that is equal to 2 plus or minus I is a value. That means it is the meaning of complex value. There is a complex unrepeated. Therefore, by using the third case, it is equal to alpha is equal to and beta is equal to 1. Therefore, you need to write in the form of e power of 2x into a cos x plus b sin x is a value. Otherwise, e power of that is a 2x into that is a c1 into cos x plus c2 into that is a sin x is a value. That is replacement of a comma b is equal to c1 comma c2. And here solve that d square x by dt square minus 3 into dx by dt plus 2x is equal to 0. Given that when t is equal to 0 and x is equal to 0, dx by dt is equal to 1. That means that x of 0 is equal to 0, that x dash of t is 0 is equal to that is a 1 is a value. This is nothing but by using the initial value problem. First of all, we need to write what is the operator form, and after that what is the auxiliary equation. That means d is equal to d by dt and d is equal to m is a value. Therefore, that is m square minus 3m plus 2 is equal to 0. By solving here, you obtain that clearly m is equal to 1 comma 2. And moreover, these are also the different roots. Therefore, you need to treat it as that is a either a in t power t plus b in t power 2t. Otherwise, that x is nothing but c1 in t power t plus c2 in t power of that is a 2t. But in this, the given problem is given that is a initial value problem. Therefore, by using the initial value condition with the help of the equation 1, what we assume here, by using this assume that general equation, by using the initial value, by solving here, a plus b is equal to 0 and again a plus 2b is equal to that is a 1 value. Now, we need to solve that equation 2 and 3. Therefore, the values are you obtain clearly a is equal to minus 1 and b is equal to 1. Therefore, the complete solution of the given differential equation is x is equal to minus e power minus t et plus e power of 2t. Otherwise, e power of 2t minus e power t is a value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.